So hi guys, as I already mentioned, so we'll just wait for a couple of more minutes, then we can start. Yeah, hi Kailash. Hi Kailash. So as some students are joining in, so let me just again briefly mention the instructions. So the instructions will remain same, but we are bound to repeat them every time we join. So I'll just start at 3:05 p.m. because some people are still joining in. And also I'd like to mention that whenever you have some doubts, I'll give you time after every problem is solved. I'll give you some time to ask your doubts, so try to ask your doubts first in chat box. If it's not convenient, or if I am not able to get it through the chat box, I'll ask you to unmute your microphone, so then you can ask through the microphone. And also everyone is requested to turn off their microphones and camera all the time. It should be shut all the time. So we'll just start after 3 minutes. And also as I said last time, and I'll repeat it again, that I'll be only adding new participants whenever I solve any particular problem, because in between I won't be able to just shift to Google Meet and solve and then go back again to the PowerPoint. So I'll just wait for that problem to be solved completely, then I can move admits and students. Also, if someone had any still has any doubts, someone has still any doubt, so we can just repeat at the end also. So Kailash, as I mentioned last time, so we'll be discussing according to the week number. So last week was our first lecture, so first live interaction session. So week one related problems were discussed. In this live session, week two related problems will be discussed, and afterwards three, four, and so on. So this is a week two live session. You can say a week two live session. Yeah. So it's 3 4 p.m. and someone has joined in. Okay, it's 3 5 p.m. I think we should start. So Wait a moment. Yeah, week 2, I saw it in fact today also, that week 2 related problems have been submitted, but I think we can discuss week 2 related problems, because uh, the sequence is going like that. So every time I think we will be delayed. I don't know this time. Last time we used to discuss those assignments which were problems related to those assignments which were not submitted, but this time I think they have shifted it. So I think, but we will be discussing week 2. So let me just share it. It's getting delayed. So can anyone just confirm that is my screen visible? Okay, so let's start. So hi everyone, my name is Musab Rafiq. I'm a PhD student in the Department of Electrical Engineering at IIT Kanpur. So I'm your course TA for this course, Digital Electronic Circuits, that's taught by Professor Gautam Saha from IIT Kharagpur. So every week we meet at on Sundays from 3 p.m. to 5 p.m. and we'll be discussing problems related to that week particular tutorial. So this week we are going to discuss problems related to week 2 material. So week 2 material will consist of this: basic logic gates, and or gates, positive and negative logic, and all those things. I hope you have gone through the lectures, and also I'll be discussing the problems related to the assignments. Not necessarily the same problems that you had in the assignments, but somehow along those lines I'll be discussing. So let me just admit some participants first. So let's just start. So now I won't be admitting any participants till I solve the first problem. Then I can add the participant, and I'll also be giving you time to ask in your doubts if you have any after every particular problem is solved. So just start. So this is our first problem. The problem asks us, simplify the following Boolean expression: f is equal to bc plus bc bar plus ba. So when I am saying this plus or this means or operation, you know that. Huh? So the question asks us to simplify the following expression. So we need to simplify this expression. So let's just start. So it's given as f equal to bc plus bc bar. So bar means complement, you know that, and this is b a. So we have to simplify it. So when we look at the function, so what we have here is we have a b common between these two terms and also these two terms. So let me just take the first two terms. So I have b and I have c plus c bar, and then I have ba. So there's one thing, I would have taken this b common here also. The reason why I took this only because I know this c plus c complement thing. It will give me a simplified expression. So you know this, when we have x, let x be any variable and its complement x bar. So when they are in OR operation, when we do OR operation on them, the result is always equal to 1. Why? Because let's say if x is equal to 0, x bar will be 1, and if x is equal to 1, x bar will be 0, and one of them will always be equal to 1, and we know that our operation output is 1 if any of the input is 1. So that's why x plus x bar is equal to 1. So this thing is 1. So we have f equal to b dot 1 plus ba. So b dot 1 means b is in AND operation with a signal that is always high. So this thing will be equal to, so we know that b dot 1 is equal to b. So it will depend on b. If b is equal to 0, it will be 0. B is equal to 1 equal to 1. So we have f is equal to B plus BA. Now what we have in common is F equal to, we can take B common out of this, B, and we have 1 that is in OR with A. So we know that 1 OR with any signal is always equal to 1. So this thing will be reduced to 1. So F is equal to B and with 1, that implies F is equal to B. So this is a simplified expression for this thing. So F equal to B, so option A is the correct answer to this question. So let me just admit some students, and if you have some doubts, please type it in the chat box. So someone has written answer is B, option A, and no B. Okay, so Kailash has also done it. So is it clear, or should I repeat it, or we can proceed? So I think you don't have any doubts in here, or we can proceed. Okay. So question 1 is done. If someone has any doubts or someone wants me to repeat this, he or she can text it at the end, so I will repeat at that time. So now we have the question, simplify f of a, b, c. So we have a function of 3 variables, f of a, b, c, where we have given this f is equal to a dot b plus a dot c complement plus a b c, and we are again asked, the question is again asking us to simplify the expression, Boolean expression. So here what we'll do, we'll just first write the expression that has been given to us. So f is equal to f of a, b, c is equal to a dot c complement plus a so this is AB, we'll write it right this, and this is AC complement plus, so what we'll do is we will use distributive law here. So we'll write A B bar C A B plus A B bar C C. So now we write it as A B plus A C bar plus, now we will use commutative property. We write it as A B bar B C A plus, so we know that A dot A is equal to A. So by dot I mean AND operation. So C dot C will be C only. So it will be A B bar C. And also one thing is here, we have B ANDed with its complement. So B dot B bar is equal to 0. So this entire term will vanish and it will be equal to 0. So then we have AB plus A bar C plus A B bar C. Now I can take this A and A common here. So I have A, let me just first write it like this, you might get confused. So we have A AB plus AB bar C plus A bar C. AC bar, sorry, it's AC bar. Now we'll take a common here, and we have b plus b bar c, and then we have a bar c. Now we will use a property here which is called adsorption law. You might have studied in the lectures. So if we have something like this, x plus x bar y, that thing is simply equal to x plus y. So this thing is a times, so here x is b and y is c, so this is a times b plus c plus ac bar, correct? And now I'll continue on to the next slide. I think okay, I'll continue on to the next slide. So I will have a new slide here. So what we have here is we have a b plus c plus ac. Now we'll use the distributive law. We have ab plus ac plus ac bar. So here take a look at these two terms. So this is AC and then is OR with AC complement. So for simplicity, let me just put AC equal to X. Let's just say AC equal to X. So what I have here is AB plus X bar. So as you saw earlier, this thing, what is this thing equal to? X plus X bar. This thing is always equal to 1. So let's just say if x is equal to 0, x bar will be 1, and if x is equal to 1, x bar will be 0. So when any of the signals is high, the output of our operation is always 1. So this thing will always be equal to 1. So AB plus 1. So we have we have OR operation of AB with 1, and we know when any of the input for an operation is 1, the output will be 1. So we have F is equal to 1. So F will be high always. So this is our simplified expression, and option B is the correct answer to this question. So the simplified expression for this is equal to 1. So Jagannath Naik has asked the question, sir, where do we get the PDF of previous and this lecture notes? I think they should have uploaded it in the portal. They have not uploaded it. It should be uploaded somewhere. So what you can do, you can mail the NPTEL guys, or I'll just mail them to kindly make them available. So then I think it should be available. I'll just mail them today. Hopefully I'll mail them. You can also mail them at your own end, but I'll also try to mail them today, and let us see what we can do. So any doubts in here in this question, or should we proceed? So we were at question number 2. So now we have to discuss question number 3. Okay, so question number 3. So question number 3 is on this number system. So we have a hexadecimal representation. So we have given a number in octal system, and we are asked to find its hexadecimal system. So I'll show you the two ways. One is the long, the detailed process. Another one is a shortcut, but we should always prefer the long one when we are doing it initially in our starting days. Then once you get the hold of the subject, you can try to use another method. So what we have here is we have 657 in octal system, and we have to find its decimal representation, sorry, hexadecimal. So octal system is means to the base 8, hexa is to the base 16. So what we do, we will first convert the number to the base 10. So how we'll do it, we'll just take the base and multiply the face value at that thing. So we have 7 plus 8. So what we have here is 5, and then it's 8 square multiplied by 6. So in decimal it will be equal to, so 8 power 0 is 7, this will be 7. So 8 multiplied by 5 will be 40. 8 square is 64. 64 multiplied by 6. So 624 by 384. Now I'll just add them up. 384 plus 40 is 424, and 424 plus 7 is 424 plus 7 is 431. So the number in decimal system is 431, but we are asked to find the number in hexadecimal system. So what we'll do, we'll just take 431 and divide the number by 16. So 16, how much? 16, 20 is 320, so it will be somewhere between 1625, 1625. So this is 1626 minus 431. So this is 16 times 26, and the remainder will be 15, and then we have 16 times 1, and the remainder will be 10. So 10 in hexadecimal is represented by A and 15 by F. So we have this 0 to 9 as 0 to 9. 10 is A, 11 is B, so on, and 15 is F. So the number in hexadecimal system will be, so this thing and this thing in hexadecimal will be 1AF. So this is the hexadecimal representation of number 6567 in, that was in octal. Now another way we can do it, we have this 657. We can write first, we'll convert this 657 to binary. So I'll do it, we'll take one digit 7 and write its 3-bit binary for write it in 3-bit binary format. So 7 can be written as 1 1 1, so make a set of 3, and then 5 can be written as 1 0 1, and 6 will be 1 1 0, correct? And now take 4 bits together, 4, these 4, this 4, and here you can add zeros in between in at start. So we have 1 1 1 1 1, that is 15, so that is F. And then we have this 4 1 0 1 0, so this is 8 plus 2 is 10, so we can write A, and this is 1, so we'll get 1AF. So this was another way. So the answer to this question is 1AF. Any doubts? I can see some of you have solved it already, but still, if anyone has any doubts, please write it in the chat box. Please explain once. So first one, that was the elaborative method. You want me to explain it again? I'll just do it. So these are basic questions. Here also the level will increase in the start, and in fact from next assignments level will be much more harder. So this is the basics. These are still the basics. In last time when I discussed the questions, they were related to week 1 assignments. I saw week 1 assignments. The questions were along those lines only. Maybe the reason you find it easy because you are doing it in real time with me. That's this thing. That there is one more thing. Right now these are simple questions. These are based on the number systems. But as we move forward, the level will increase, and most certainly the level will definitely increase in the assignments that are coming up, week 3. So and onwards. So I'll just repeat the method first. Someone has asked me to repeat the method first. So what I did, I showed you the two methods, and the first method, that was the elaborative method. What I did, I first converted the octal number that was in base 8 to decimal number. So how I did it, so I took the base and multiplied the the index value and the number at that value. So 8 to power 0 multiplied by 7 plus 8 to power 1 multiplied by 5 plus 8 to power 2 multiplied by 6, right? And then I added them up, the result, and I got 431 in base 10, that is the decimal number system. So this number system, I converted the answer to hexadecimal by simply dividing it by 16 and writing down the remainders here. So when we divide 431 by 16, so how we divide it, we have 16 multiplied by 26 and we have remainder 15. Then we divide 26 by 16, we have 16 1 and remainder 10. So we have 1, 10 and 15. So our answer will be 1, A and F. 15 is F, 10 is A and 1 is 1. So my answer is 1AF. And for the other method, what I did, I took the octal number, I converted it into binary, and then from binary I converted to hexadecimal by taking 4 bits individually. I'm not sure what will be asked in the final exam, but it will be definitely along the lines of assignments. So if you solve assignments and attend the live session, that will be definitely helpful, because you don't know what will be in there in final exam, but it will be along these lines only. So it will definitely be helpful. Now we'll move forward to question number 4. So the question asks, which of the following in place of question mark, which of the following in place of question mark will make the function f of a, b, c, it is the sum of the minterms, self-dual. A self-dual function is whose dual is the function itself. So that is a dual function. So what we have here, self-dual function. So f of a, b, c, it is a 3 variable function. A, b, c, it is the sum of minterms 1, 2, 4 and the question mark, what should be in place of question mark, so that the function becomes self-dual. So when we have is 1, so let me just first write the truth table of 3 variables. 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, 1, 1. So this is, so when we have this 1, so this 1 will be A, B, C. So this one will be A bar, B bar, C, and its dual will be, one's dual will be, so when we do the dual, it will be A, B, so A, B, C, that is A, B, C bar, that is 1, 1, 0, that is 4, that is 4 plus 1 is 5. So 5 can't be here. Then we have 2, 2 is 0, 1, 0, that thing its complement will be 1, 0, this is 6, 6, 6, sorry, this is 6, then it's 1, 0, 1, so 5 can't be there, so 5 can't be there, 6 can't be there. Then we have 4, 4 is 1, 0, 0, that implies 0, 1, 1, so that means 3 can't be there, so we are left with either 0 or 7. So both 0 or 7 can be there. Since the option doesn't have 7 and option has 0, so 0 will be answer. So what basically we did here is, we have the minterms 1, 2, 4 and 0, and when we do its dual, we'll get the dual f of d, that is will be equal to pi of the remaining terms, that is 3, 5, 6, 7, which is simply equal to sum of minterms 1, 2, 4 and 0. So as a result, we got the dual of the function equal to function itself. That's why it's you can say the corresponding complement should not be there, so for this and so for this. And here we had two options, 0 and 7. So out of those two we can put any of it here, but the option didn't have 7, so that's why we did put this equal to 0, and once we put this equal to 0, the function will be a self-dual function. So the correct answer to this question is option A, 4. So any doubts, or should I proceed to the next question? Okay. So the question asks us what should be here, which min term should be here, so as to make this function a self-dual of itself. So what is a self-dual function? So when we take a dual of a function, it should be the function itself. So what is meant by dual? That all the OR operations get replaced by AND operations, and all AND operation get replaced by OR operations, and if there is a 0, it gets replaced by 1. If there is 1, it gets replaced by 0. So once we take the dual of this, we know it will be to make it a self-dual, the complements of these should not be there, it should not be here. But what I mean by complement, so as we have here 1, so 1 is 0 0 1, so do the complement 1 1 0, that means 1 1 0 should not be here, because once we do this 1 1 0, which means we have this pi means max terms pi of 6, so pi of 6 will signify summation of 1, which means sum of min terms. So in order to get back the 1, we can't put 6 there. So in order to get 2 back, we can't put 5 there. 5 means this term. 5 means which term? A, B bar, C. We can't put that term here. And for 4, this is 3, so we can't put A bar, B, C here. So we are left with two options, 0 and 7. So what is interesting about the 0? If we put, we can put any of the two, but one thing is here, option doesn't have 7. So option couldn't have, options will not have both these 0 and 7. Only one should have been there, and that's what it is. Only 0 would have been there. If option if 7 would have been in the option, 0 would not have been there. So as 0 is in the option, we can put A equal to 0 here. So what we get here is, so let me just insert a new slide. So once we put f is equal to 0, we are left with f is equal to summation of 0 1 2 and what was the other term, 4. So once we do the dual of this, fd will be equal to pi of 3 5 6 7, which will be equal to sum of min terms. This was max term, this was sum of min terms, 0 1 2 4. So the dual of the function is function itself, so this is a self-dual function. So we couldn't have put these three numbers here. If we would have put it there, we would not have gotten the function back. So that's the reason. So now moving forward to, this was question number 4. Now moving forward to question number 5. So yeah, dual and self-dual are different. Yes, this thing should have been there in the lectures, I think. If you have still any doubts, you can refer to the lecture. If still some doubts remain, we can clear it next time. We can surely clear it next time. So now moving to question number, what is question number 5? So convert the following Boolean expression to equivalent canonical form, sum of products. So we have to form a sum of product expression for the following function. So the function is a 3-variable function, f of x, y, z, So we have here is xy complement plus yz complement. So in order to make this in the standard canonical sum of product form, so what we'll do here, so missing variable here is z. So what we'll do here is we is xy bar and we'll just add it with z plus z complement. So first see whether this is the correct thing we are doing. So this z plus z complement is always equal to 1, so this thing will not change. And also the missing literal variable here is x, so we'll add like this, x plus x complement times yz complement. So what we'll have here is x y complement z plus x y complement z complement, then x y z complement, then x complement y z complement. So this is the canonical form sum of product form. So we'll just see which of the options correspond to this. So we have this term xy complement z, so xy complement z, xy complement z, xy complement z, so this is here xy complement z, so this and this has xy complement z, and then there is xyz complement, xy complement z complement, xy, so this is here and this is here. Then we have xyz complement, that is here and also here, and also we have x complement yz complement, that is here. So option C is the correct answer to this question. Dual deal with AND to OR to AND. Self dual is AND to OR to AND A to A bar. No, A to A bar like that, no, that is complement. A to A bar is complement. Dual is OR operations get replaced by AND operations get replaced by OR operations, and if there is any one constant 1 in there, it will replace by 0. For a complement we have a different thing. That time A gets changed by A bar and all ones will be equal to zeros. Dual AND operator gets changed by OR operator gets changed by AND operator, and constant 1 gets replaced by constant 0, or constant 0 gets replaced by constant 1. That is the dual. Now this was a pretty much straightforward question. Now we can move forward to question number question number 6. So this is another simple question. Convert the binary number 101102 to an octal number system. So I will again show the two methods. I'll just go quickly through this question. This is a relatively simple question, but I'll just try to go quickly through it, but I'll show you both methods that I have already discussed. So we'll first convert into the decimal number system like this. I'll be quickly going through this. So 2 to the power 0 is 1 plus 2 to 0 plus 4 plus 8 plus 16 plus 64. 2 to the power 6 is 64. So 64 plus 16 is 80, 80 plus 8 is 88, 88 plus 4 is 92, and 92 plus 1 is 93. So this thing is 93 in base 10. And now we'll have to find the octal number, so we'll just divide it by 8. So 8 11 is 88, so remainder will be 5. 8 1 is 8 and remainder will be 3, so it is 135 in octal number system. And another way was that we could have taken a 3 bits combination, and here we could have added 0 0. So 101 is 5, 0 1 1 is 3 and 1 is 1, so this is 135. So I think all of you have done it. And that's the reason I went quickly through it. Now another question, that is question number 7. So this is, let f1 equal to x, find out the output of the following expression. So we are given with this expression where n is an odd number. So we are required to find the output of this expression when n is an odd number. So what we have here is f1 is equal to x and fn of x is equal to fn minus 1 bar here signifies complement plus x. So we need to find the output of this expression when n is odd. So what we'll do here is we'll just put the n equal to 1 2 3 first and see what's the trend that follows. So f1 is equal to x. So if f1 is equal to x, what will be f2? So f2 will be equal to f of 2 minus 1 complement plus x, referring to this thing. So f of 2 minus 1 is f of 1 complement plus x. So what is f1? f1 has been given as x. So it is x complement. So it is x complement or with x. So we have been discussing this thing for a long time. So whenever x plus x complement is there, so we know that f2 will always be equal to 1, right? Now put n equal to 3. So n equal to 3 means f of 3 is equal to f of 3 minus 1 plus x. So f of 3 minus 1, that is f of 2 complement plus x. What is f of 2? We just found out it was 1. So 1 complement will be 0 plus x. So f of 3 will be equal to x. So we saw here f1 of x is equal to x, f3 of f3 is also equal to x. So whenever n is odd, you could try it for 4 5 also. Whenever n is odd, my f is equal to x, and whenever n is even, my f is equal to 1. So for n equal to odd, my f is equal to x. So this is the correct answer to this question. Some of the students have done it. Now this was question number 7. Now moving forward to question number 8. So this is a question I would like you to do first. So we are given this number BCA in hexagonal system, and we are just required to find the answer in the decimal number system. So this is a, you could do it here, then after everyone has done it, I will repeat it. So I'll just like you to do it first, and then I will show you the solution after 5 minutes. So I don't think it will take 5 minutes. I'll just wait for 2-3 minutes, and then I will show you the solution. I don't, maybe for base 4 there is some this name, but I don't think for 5 there is. It's not necessary that every number system will have this, or what's called the name, but you can Google it and check it whether there is any name for that. I'm not sure about 4. Binary, octal, decimal and hexadecimal, these are the 4 systems. Oh wow, Venkata has done it already, but I'll just wait for another couple minutes for others to do it, then I will show you the solution. Don't write the answers, not required, but you should do it at your end. It will be a good practice. So it's 3:44 p.m. 3:46 p.m. I'll be showing you the solution. Yeah, option B is correct, Kailash. The reason why I'm showing these questions, because sometimes these questions appear to be easy, but people, when a lot of questions are there in exam, people tend to make silly mistakes in doing the easy questions. So and also I thought number system has been discussed, so let's just give some questions related to that also. So since we have some time, so are you guys all from the bachelors, or some of you are in job and all? So okay, it's nice you are doing NPTEL course in bachelors. These are already helpful. So has everyone done it? So it's 3:46. I assume everyone has done it or at least tried it. So let me just show you the solution. It's quite straightforward. I'll just go through it quickly. So we have number BCA in 16 radix 16 system, and we just need to convert it in decimal system. So what we'll do here is, I'll just first write that 0 to 9 in hexadecimal are 0 to 9, then 10, 11, 12, 13, 14 and 15. They are represented by A, B, C, D, E, F respectively. So BCA will be BCA to the base 16. So we'll just find the decimal equivalent of it. So it will be 16 raised to power 0. So number here is A. So A has value 10. So it's 10 plus 16 times 1 plus C is 12 plus 16 square multiplied by B is 11. So 16 square is 256. 256 multiplied by 11 plus 12 multiplied by 16 plus 10. So 256 times 11 is 2816 plus 16 times 12 is 192 plus 10. So this thing adds up to 3018. So that is your answer in base 10. Now moving forward to this question number, what is this question number 9? So we have this simplify the boolean function f of p q r s. So we have a 4 variable boolean function which is the sum of mint equal to, let me just admit someone has joined in. So we are given this boolean function which is equal to f is equal to pqrs equal to sum of minterms 2, 3, 4, 5, and also we have the don't care conditions 10, 11, 12, 13, 14, 15. So we'll just solve this thing using a k-map. So for a 4 variable k-map, first let's just write the expression that is been given. So we have f of p q r s. So this is equal to sum of minterms 2, 3, 4, 5 plus we have some don't care conditions here that are 10, 11, 12, 13, 14 and 15. So now we have k-map, 4 variable k-map. We'll just construct the 4 variable k-map. So we'll just divide it in 4 columns and 4 rows, and here you will just write your variables pq in this order only, pq, and here we have rs. So here what is we have is 0, 0, 0, 1, and here it's 1, 1, make sure of it, and here it's 1, 0. So it is 0, 0, 0, 1, 1, 0, 1, 1. So here it will be minterm number 0, here it will be minterm number 1, here it will be minterm number 2, and here it will be minterm number 3. Here 4, 5 and 6 will be here, and 7 will be here. And now skip this row. 7, 8 will be here, 9 will be here, 10 will be here, and 11 will be here. Then we have 12, 13, 14 and 15. Now I'll just mark those minterms which are equal to 1, and also the don't care conditions which are represented by cross. So the minterms for which value is 1 are 2, 3, 4, 5. So 2 is here, 3 is here, 4 and 5 is here, right? And the minterms, the don't care conditions are 10, 11, 12, 13, 14, 15. So 10 is cross, 11, 12, 13, 14, 15. So now just see if we can make any octet out of it. No, we can't make any octet out of it. So the next possible thing is, can we make a square out of it? So yes, we can make square out of it using the don't care condition. So we can have this square, and we can have this square, which will convert all the ones. So what will this represent? So this is 0, 1 and 1, 1, and here it is 0, 0 and 0, 1. So 1 is remaining constant, so q. And what is the other term? So 0, that is r bar. So qr bar, this square will give us the term qr bar. Now this square, so here it is 0, 0 and this is 1, 0, this is 1, 1, this is 1, 0. So r is not changing, so we will have r, and also 0, 0 is remaining there, so q is changing, it will be q bar. So my simplified expression will be the sum of these two terms, so it will be qr bar, that is qr complement, plus rq bar. So what is this thing? This thing is an XOR operation, so it is q XOR with r. So the answer is option C, q XOR with r. Oh, some of you have done it. So some of you have done it. Okay. So any doubts regarding this question? So should I proceed? Okay, now moving forward to question number, this was 9, now 10. So question number 10 asks, what is the minimum number of gates required to implement Boolean function a, b plus c if we have to use only 2 input NOR gates? So using only 2 input NOR gates, you have to implement this function, and the question asks us what are the minimum number of gates required to implement the function. So the function is f equal to a, b plus c, and what we'll do, we'll just convert this expression so in NOR expression form, and we'll just see how many NOR gates will be then required to implement the function. So this is f is equal to a, b plus c, so we can write it as c plus ab using the commutative property. So you might have seen this adsorption law. So this c plus ab is equal to c plus a times c plus b, right? So f is equal to c plus a times c plus b. So what I did here is I got an expression in terms of the OR expressions. Now what I will do is I'll just take the 2 times complement. So f is I can write it as f complement whole complement. So this thing will be here equal to c plus a c plus b complement and then whole complement. So let me just take this complement. So this complement c plus a times c plus b whole complement plus c and plus c. So this will be equal to, so when we're using De Morgan's law, so what De Morgan's law suggests, a dot b complement is equal to a complement plus b complement. So here a is a plus c and b is b plus c. So this thing will be reduced to c plus a complement or c plus b complement then the whole complement. So what we have here is we have this c plus a complement plus c plus b complement and then whole complement. So this thing here is one NOR operation, this thing here is another NOR operation, and then the combined answer to them will have another NOR operation. So in total we will have 3 NOR operations, and as such we will be requiring 3 2 input NOR gates. So what we'll have here is this thing is requires one NOR operation, this thing here requires one NOR operation, and then their sum and their this operation which is having this complement here will require another NOR operation. So the minimum number of 2 input NOR gates required to implement this function was 3. We required 3 NOR gates. So I can see some of you have solved it. You can just do it as an exercise, how many NAND gates you will be requiring. So I think it should be same. So tell again from wherever you are taking bar of f. So what I am doing here is I am just trying to write it in the NOR form, that is first OR form and its complement. The moment I got an idea regarding this, I know this is a OR operation, I got it in OR form. So I'll just take the complement. The reason I am taking this 2 times complement because I want it to be equal to f only. And as a result I got this expression, and then I use the De Morgan's law. So I got this thing in NOR form and this thing in NOR form, and then their answer is also in NOR form. So that's why I took this complement here. So I think it should be clear. Now moving to question number, what is this? This was 10, and now question number 11. So the 11 asks us find the minterms of the Boolean function. So we again have to find the what will be the minimum Boolean minterms of the Boolean function. So it is a 4 variable function with the order f is equal to w of x, y, z, and here we are given this function. So we will just first write the function as it is: x, y bar z plus x bar y bar z plus w bar x y plus w x bar y plus w x y. So if you want to find the minterms, we will have to see which variable is missing. Here w is missing in these 2 variables, and here the variable z is missing. So what we'll do here is we'll just write w plus w bar x y bar z plus w bar x bar y bar z. Here z variable is missing, w x y z plus z bar plus w x bar y z plus z bar, and then we have here the last term which is w x y z plus z bar, right? and now we'll use the distributive law. So we have w x y bar z plus w bar x y bar z plus w x bar y bar z plus w bar x bar y bar z plus w bar x y z plus w bar x y z bar. So I have reached here. So then I'll write here w x bar y z plus w x bar y z bar plus w x y z plus w x y z bar. So we now have to find the numbers corresponding, minterm numbers corresponding to them. For that I will use another color. So this is w, so this is 1 1 0, so this is 1 1 0, this is 1 1, this is 1 1 1, 1 1 1, and this is, so let me list, this was w x y y bar. Okay, this is y bar. So this is 1 1 0 1, then it is 0 1 0 1, then it is 1 0 0 1, then it is 0 1 0 0 1, this is 0 1 1 1, this is 0 1 1 0, this is 1 0 1 1, this is 1 0 1 0, this is 1 1 1, this is 1 1 1 0. So 1 1 1 0 1, this is 8 plus 4 is 12, 12 plus 1 is 13, this is 13, this is 4 plus 1 5, this is 5, this is 8 plus 1 9, this is 1, this is 7, this is 6, this is 8 plus 2 is 10, 10 plus 1 is 11, this is 8 plus 2 10, this is 15, this is 111, that is 8 plus 4 is 12, plus 1 is 12 plus 2 is 14, this is 14. So we have 1 1 1, we have 1, we have 1, then we have 5 6 7, 1 5 6 7, that is this option, 1 5 6 7 9 10 11 13 14 and 15. So the correct answer to this question is option D. So Kailash, I'll just come to the end. So I'll just write here question 10 needs to be revisited. So question 10 we'll just see it again at the end. Is that fine? And for this question, are there any doubts? So here there are no. Prashant, do you have any doubts? I think it's regarding question 10. I think we can come to that at the end. Was it related to question 10? We'll just discuss again it at the end. So was there any other doubt? Okay, no issues, no issues. So you have pressed it excellently, so no issues. But still we'll discuss question 10 again at the end. So question 11 I think is done. So now we can move to question number 12. So question number 12 asks us, is addition where we have given these two hexadecimal numbers and we have to add them up and we have to give the answer in hexadecimal system and also in decimal system. So what we'll do here is we'll just add them in hexadecimal system, and then the answer will just convert it into the decimal system. So what we have here is we have to find b a 3 to the base 16 plus 5 d e to the base 16. So we'll have write it like this: b a 3 and then write it is 5 d e. So we have a b c d e f. So these are 10 11 12 13 14 15. The reason why I'm writing this again because I used to get confused with these. Sometimes I used to write 14 for some other variable and some more, so that's why I'm writing it again. So we have 3 plus e, so e has value 14, so 3 plus 14 plus 3 is 17. 14 plus 3 is 17, and 17 in hexadecimal will be 16. So we'll divide 17 by 16 and it will be 1 1. So the sum will be 1 and the carry will be equal to 1. And then we have a plus d, so a is 10 and d is 14 and we have 1 carry. A is 10 and d is 13. So this is 10 plus 13 is 23. 23 plus 1 is 24. 24 in hexadecimal will be, so 16, 1 is 16 and the remainder will be 8. So 8 and carry will be 1. And then we have b is equal to 11 plus 5 plus carry 1. So 5 plus 1 is 6, 6 plus 1 is 7, and we have 17 again, that was 1 1. So we'll get 1 and we'll just write another one here. So 1181 in hexadecimal system is its correct answer, and we have to write this answer also in decimal. So we have done it a couple of times, so it will be pretty easy for all of us. So we'll just write 16 to the power 0 plus 16 raised to the power 1 multiplied by 8 plus 16 square multiplied by 1 plus 16 cube multiplied by 1. So 16 cube is 4096. Then we have 16 square multiplied by 1, that is 256. Then we have 16 into 8, that is 128, and finally we have 1. So if you do the addition, this thing will be equal to 4096 plus 256 plus 128 plus 1. So this will be 4481. So our answer is 1181 in base 16 and 4481 in base 10. 1181 in base 16 and 4481 in base this. So it is option C. So any doubts here? I think this was a simple question. I don't think there will be any doubts here. Okay, excuse me. Now moving forward to another question. That is question number, this was 12, so now we are 13. So we have this question: a logic circuit implements Boolean function f of a b c equal to a bar b plus a b bar c bar. Afterward, it was found that input combination a b equal to 1 can never occur. So this input combination can never occur, a equal to b equal to 1. Taking this into account, a simplified expression for f will be, so we are given this f and we are, someone has joined in, let me just admit. So again I will just repeat the question. Our logic circuit implements a Boolean function f of abc equal to a bar b plus a b bar c bar. Afterwards, it is found that input combination a equal to b equal to 1 can never occur. Taking this into account, a simplified expression for f is, so we are given this function f is equal to a bar b plus a b bar c bar. So we have been given that f, after it was found that a equal to b equal can never occur. So what we'll do, we'll just write the expression in terms of min terms first. So we'll just write like this: a bar b c plus c bar. So we'll just find the min terms first, plus a b bar c bar. So we have a bar b c plus a bar b c bar plus a b bar c bar. Now I'll just write the truth table of this: a b c 0 0 0 1 0. So this is 0 1 0 1, and this is our y. So this thing is equal to a bar is equal to 0 1 1 0 1 1. This is 1. a bar b 0 1 0 0 1 0 1 0. Here 1 also. So this thing is 0, this thing is 0. Then we have a b bar c. So 1 0 0 1 0 0 1 0 1 is 0. So this is a truth table for this, but there is one more condition, that a equal to b equal to 1 can never occur. So what is this? So a equal to b equal to 1 will become a don't care condition for us. We don't care about them because it can never occur. So this thing becomes a don't care, reflects in this truth table as the don't care condition. So this becomes a don't care conditions for us, because a equal to b equal to 1 can never occur. So now it simply we can use a Karnaugh map of 3 variables and we can solve the problem. So we have a k map of 3 variables like this: a, b and c, and we have like this 0, and then we have 1. So this is 0 0 1 1 1 1 0. So we have 1 at positions 0 1 0 0 1 0 0 1 0 1 0. We have 1 here, and we have 1 at 0 1 1, and we have 1 here at 1 0 1. We have 1 here at 1 0 0, and also we have two don't care conditions at 1 1 here and here. Now let's see if we can form any chord. So yes, we can form a chord using the don't care conditions like this. Now this thing remains, so we can form a pair using not don't care condition. So with this square we get 1 1 1 is not unique. We get b, and using this pair we get a, and we get a and c bar. So the answer will be sum of these two. So it will be b plus ac bar. So we use the don't care conditions that occurred from this thing: a equal to b equal to 1 cannot ever occur. So they become don't care for us, and we got a chord of this. We got a chord, and of this we got this term b, and we got a pair we constructed using the don't care condition, and from that we got this ac bar, and our final expression was f is equal to b plus ac bar. So this is option B. So the option B is our correct answer. Okay, it's nice, some of you have done it. Now moving forward to question number, this was question number 13. Now moving forward to question number 14. Let me just use this first. Question number 14. So I'll just again ask you guys to first try this. So consider the equation 1, 2, 3 in the base system 5 and another equation x equal to x8 in base y with x and y as unknowns. So x and y are variable here. So the number of possible solutions is, so you have to find the number of possible solutions for x and y. So this is a problem. I'll just give you the 5 minutes. It's slightly bit tricky, so I'll just ask you to do it, then I will show you the solution. So this is 4:15. I'll just give you 5 minutes, 4:20, and after at 4:20 I'll just show you the solution. But first try it. I just want you to try it. I'll show the solution anyways, but I want you guys to try it first. I don't need answers. Don't give me the answers, but just try it. You can give your answers at 4:20, even if you have done it earlier. But try to give your answer at 4:20. Kailash, do it again. Xy equal to 27. You won't get it. Xy equal to 27. Do it again. I think somewhere you have done a calculation mistake. So have you guys done it? So Venkata says option B. Ramana, sorry if I mispronounce your name, but you say option B. Any other? So those who have done it, can you? So you are unable to solve. Okay, any other? Is anyone else doing so, or should I show it? So if anyone else is doing, I'll just wait for that person to solve, then I can proceed. Or if you have done it, please type in your answer. Which option do you think is the right option? So some people say option B. Okay, only one has said option B. So let me just show you the solution. So we have one number 1 2 3 in base 5, 1 2 3 in base 5, and another number is x8 in base y, correct? So the question asks us the number of possible solutions. Let me just expand this number. So let me just this number in decimal system. So we have 5 to the power 0 multiplied by 3 plus 5 to the power 1 multiplied by 2 plus 5 to power 2 multiplied by 1, correct? And also accordingly I'll expand this number. So it is 8 multiplied by y to the power 0 plus x multiplied by y to the power 1. So this is 25 multiplied by 1 plus 2 multiplied by 5, that is 10, plus 3 multiplied by 1, that is 3, and here we have only xy plus 8, right? And then we have is 25 plus 10 plus 3, so we have 38 is equal to xy plus 8. So then we have implies xy equal to 30. So now we have xy equal to 30, and when we need to see how many possible values of x and y simultaneously can be the solution to this problem. So now comes the tricky part. So xy, till then I expect everyone will get this solution, and here there are two scenarios that will be happening. So some of you, someone has given this answer b equal to 4. I know what have been missing there. So we have we have this xy equal to 30. We have two conditions will arise. So the person that gave the answer equal to 4 only considered one condition. So the condition is, we have first condition that x should always be less than y, because the number can't be greater than the base of the system, right? And the another condition is coming from this 8. So if a number 8 is in some number system, that means the base will be greater than that number system. So that implies y should be greater than 8. This is the trick part here. Y should be greater than 8 and x should be less than y. So we'll just first start from 1 and 1. So if x is equal to 1, x should always be less than y. X is equal to 1, y will be 30. So this is solution 1. Then x equal to 2, y will be 15 is solution 2, and x equal to 3, y equal to 10 is a solution, that is solution number 3. Now what is the next possible solution? X equal to 5, x equal to 5, x equal to 5, and y equal to 6. But this is not a solution. Why? Y can't be equal to 6. If y equal to 6, then number 8 wouldn't have been here. So the maximum possible number that would have been here is 5. So there are only 3 possible solutions. So the answer is A equal to 3. That's why I wrote a tricky part. Kailash, I got your point. So that's this. I think you missed that y greater than 8. Yeah. So one condition was easy to catch. Y greater than 8 was slightly tricky. So everyone got the solution. Should I proceed to the next question? Okay, so the next question will be this was question 14. Okay, 15. So the green ones I have marked them because I want you guys to do it first and I'll show you the solution. So in this lecture I decided that I'll give you the 3 questions. So this is the third question. So everyone please take a look at this question and try to do it yourself first, and then I'll show you the solution. So again I'll be giving you the 5 minutes, then I'll just show you the solution. So I'll just read the question for you. If x equal to 1 in the logic equation, x plus y plus x plus z y bar plus z bar plus xy bar, x bar plus z bar x plus y equal to 1. If x equal to 1 in this logic equation, then you have to find out what condition will arise. So I'll be just giving you the 5 minutes for I'll just be for 5 minutes, yeah, 4:30, then I'll just show you the solution. Once you are done with the solution, when done with the problem, please type in your solution, this answer. So you want me to repeat you want me to repeat question number 14, Velpula? So what I'll do, I'll just repeat question number 10 because what was his name? Kailash asked me to repeat question 10, and I'll also repeat question 14 at the end. That's fine. Okay, till then do this question. I'll just give you this 3-4 minutes, then I'll show you the solution. It's an easy question. Last one was also easy but slight tricky. This one is simple, straightforward. So some of you guys are typing in your answer. I won't give you the answer right now. When I will show the solution, I'll just give the answer. But check it once again. My cursor is not coming. So let me just show you the solution. Actually my cursor is not coming up. So my cursor icon, does anyone know what happened to it? I don't know what happened to it. So this thing is here. It's not coming. So where is it? So let me just show you the solution. Actually my cursor is not coming up, so now it is. Okay, So the question is, if x equal to 1, then the logic equation this equal to 1. So what will be the condition that occurs? So we have the function, write this, x plus z times y bar plus I'm just writing the logic equation as it is, so no step I have done here, no additional step I have done here. So this thing is equal to 1. So here the condition given is x is equal to 1, so replacing x by 1, so we have 1 plus z y bar plus z bar plus xy bar and x bar. So x is equal to 1, x bar will be 0 plus z bar 1 plus y equal to 1. So we have 1 plus something, so 1 or with anything here is equal to 1, right? So this is 1, and then we have 0 plus we have z bar, and again 1 plus y is 1, so z bar equal to 1. So z bar and with 1 is z bar, so z bar equal to 1. So what we got from this is that z bar equal to 1, so z complement equal to 1, that implies z equal to 0. So with this condition we got z equal to 0. So option C was the correct option, answer to this question. So I see some of you have done it. Yeah, Kailash, you have also done it right. So option C was the correct answer to this question. Now moving forward to question number 16. So this is also based on number system. I thought this decimal thing most of you might have seen it, but still I wanted to touch on this part. So we are given this decimal we have to find the decimal equivalent of this binary number. So we are given this binary number and we have to find the decimal equivalent of this. So what we'll do here is we'll first take this part. So this part we have done it many times. So this will be 2 raised to power 0 multiplied by 1 plus 2 multiplied by 0 plus 2 raised to power 2 multiplied by 1 plus 2 raised to power 3 multiplied by 1. And then in the decimal part what we'll do, we'll just write 0 multiplied by, here the number system starts from directly 1, but 2 to power minus 1 plus 1 multiplied by 2 to power minus 2 plus 2 multiplied by 2 to power minus 3 and plus 1 multiplied by 2 to power minus 4. So let me just open this up. So 2 to power 3 is 8, 2 to power 2 is 4 plus 0 plus 1. So this is 8 plus 4, 12, 12 plus 1, this is 13. So this is 0 plus this is 1 by 4 plus 1 by 8 plus 1 by 16. So this is, if we take LCM equal to 16, this is 4 plus 8, 2 plus 1. So this is 13 plus 7 by 16. So this is 13, and the decimal part will be like this. So this is 17, 7 divided by 16, so 0.4375. So 13 plus 0.4375, and it will be equal to 13.4375. I think you guys might have seen this, so yes, I wanted to give some recap of this. So the correct answer to this question is 13.4375. So most of you guys have done it pretty quickly. So now moving forward to question number 17. So I think I also marked this. So I'll just read the question. I want you to do this question. So you have to add two binary numbers which have this decimal fraction. We have to add two binary numbers, and then you have to give the answer in binary as well as in decimal. So the number is 110.01 and 1.011. Just add them up in binary and then give answer in binary as well as in decimal part. It will take a couple of minutes, so I'll just wait for a couple of minutes. So now it's visible. So I'll just read the question. So the add two binary numbers. Number one is 110.01 and another is 1.011. So some of you have solved it. I'll just wait for one more minute. Okay, most. Okay, right. Option C is correct. Yeah, most of you have done it. So I'll just wait for 1 minute and then I'll show the solution. Okay, yes, it's correct. So I'll just show you the solution. So we have two numbers, 110.01 and then we have to add it to 1.011. So just add it. So 1 plus 0 is 1, 1 plus 1 is 2, so that is 0, 1. So it is 1 and then we have 1 here and 1 here, so it is 111.101. so this thing is simply 7 and this is, I'll just skip some steps. So this is 2 raised to power minus 1 multiplied by 1 plus 2 raised to power minus 2 multiplied by 0 plus 2 raised to power minus 3 multiplied by 1. So this is 1 by 2 plus 1 by 8. So that is 0.2 plus 0.125. Sorry, 0.5 plus 0.125. So this is 0.625. So the answer is 7.625 and 111.01 in base 2. So option C was the correct answer to this question. I saw most of you have done it correctly. So I think we can proceed to question number 18 now. So the 18 asks us, find the sum of following binary numbers using 1's complement. So we have two numbers, plus 1110 and minus 110. So here we have positive number and negative number, and the positive number is much larger, is greater in magnitude, so we'll use 1's complement like this. So we have the number plus 1110, so it will be represented by like this, 0 1 1 1 0. So this represents the sign, 0 means plus 1 and 1 means negative. And then we have minus 1 1 0 1, so it will be written like this, 1, and we have to take its complement. So it will be, by complement we have to change all zeros to 1, so it will be 0 0 and all ones to 0 1 0. And now we'll add the two numbers, so we have 0 1 1 1 and we have 1 0 0 1 0. We'll just add them up. So this is 0, 1 plus 1 is 0 1, 1 plus 1 is 0 1, 1 plus 1 is 0 1 and 1 plus 1 is 0 1, and this carry term will get added to the LSB. So we'll be having 0 for the sign, 0 0 0 0 plus 1, and we'll get 1 0 0 0 and 0. He simplifies signs and just simplifies the sum. So the answer is 0 0 0 1 but plus. So the answer is option D. So any doubts regarding this question? I see there are no doubts, so I think we can proceed to the next question. That is the last question of today's live session. So the question asks, find the sum of following two negative numbers represented in a sign plus magnitude register using ones complement. So it's again just like the previous question, but here both of the numbers are negative and we have to use the 5-bit sign 5 plus magnitude bit register. So this is 1 minus 1 0 1 0. So in sign 5-bit register it can be written as 0 can be written as 1 for the sign 1 0 1 0, and the number another number is minus 1 0 1 0 1, so that will be 1. So replacing all zeros by ones and all ones by 0, so 1 1, that will be it will be right this. So first I'm writing the number itself. Now taking the ones complement, so I'll just take the ones complement of the number of both the numbers since both of them are negative. So this will be 0 1 0 1 and this will be 1 0 1 0. Now I'll just add them up, these two numbers, 1 0 1 0 1 and 1 0 1 0. So this is 1 1 1 1 and 1 plus 1 is 0 and this is 1. So this will carry will go around and will get added to LSB. So this is 0 1 1 1 1 and this will be added to the LSB. So 1 plus 1 is 0 1, it will be 0 1, it will be 0 1 and it will be 0 1 and here it will be 1. So the sign bit comes out to be in the 1 and this is the result which will be complemented to get the answer. So the complement of 0 0 0 is 1's complement is 1 1 1 1 and this represents the sign. So this means the answer is minus 1 1 1 1 1. So option sorry, option B is the correct answer. Sorry, option B is the correct answer to this question. So someone has written once again explain this. So I presume that was for question 18, the previous question, right? And someone has written, sir, MSB is 1, so even number na sir. So what has to this do with MSB and this even and odd? I think you got confused somewhere. So Ashwini has written repeat this. So I presume it's for question 18, right, Ashwini? Okay, so I'll repeat question 18, then I will move to question question 14 and finally to question 10. So this was the last question of today's talk. So now I will go to question 18, then 14 and then 10. So what we have here is I'll just change the ink color. We have given two binary numbers and we have been asked using one's complement find their sum. So we have 1110 and 11101. So this is a positive number, this is a negative number one, and positive number is having more magnitude than negative number. So positive number will be written like this: 0 1 1 1 0, and negative number is minus 1. Minus will be present by 1, this is the sign bit. It will be by 1 1 0 1. So its complement will be what will be its complement? 0 0 1 0. Now we'll add the two numbers, so it will be 0 1 plus 1 is 0 1, 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 and the carry will go here, which will be added to LSB. So it will be 0 1 0 0 0. This will signify the sign and this will be our sum. So that is what it is. And just a moment, someone has asked me to repeat question 4 earlier. So question 14, sorry, question 14, yeah, this question someone asked me to repeat it. And then question 10. So we have given this number 1 2 3 in base 5 and x8 in base y. So we have been asked to find the number of possible solutions for x and y. So 1 2 3, I'll just convert it into the decimal. So it will write it 5 raised to the power 0 multiplied by 1 plus 5 raised to power 1 multiplied by 2 plus 25, simply 5 square. So this will be 25 plus 10 plus 3. This is 3 here, sorry, I had written 1 earlier. So 25 plus 10 plus 3 is 38. So left hand side will be equal to 38. Now right hand side, is y raised to power 0 multiplied by 8 and plus y raised to power 1 multiplied by x. So it will be xy plus 8 and this will be xy plus 8, and when you shift 8 to left hand side it will be xy equal to 30. Right, now we have the scene where x and y product is 30. So what are the possible conditions we can put on x and y? So the number one condition, x and y are both integers, that's fine, positive integers. So other than that, what is the condition? X should be less than y, because the number value cannot be greater than its base, so x is less than y. And the another condition we can put here is we see that number 8 is in the system, that means y should be greater than 8. So keeping these things in mind, these conditions in mind, so let me just first start with x equal to 1, so that means y equal to 30, x equal to 2, y equal to 15, both satisfying the conditions. X equal to 3 and y equal to 10, again satisfying the condition. Next possible solution with x and y as integers is x equal to 5 and y equal to 6, but y can't be equal to 6 because number 8 is already present here. Base of the number should be greater than the number present here, so it should be greater, y should be greater than 8. So only 3 possible solutions are there for x and y, so that's why I have to written as correct answer to this question was option A, 3. Now question 10 was asked, so what I have done here is I have function a, b plus c. I first try to write it in the OR form, so I have using the adsorption property, so a, b plus c can be simply written as a plus c and a plus b, right? Now this is my function. So to get into the NOR form, I had to complement twice, because f is equal to f complement whole complement, so this thing will be equal to a plus c, a plus b complement whole complement. So using this complement I am using De Morgan's law, so a plus c dot a plus b complement will be equal to a plus c complement plus a plus b complement. So this is one NOR operation, this is another NOR operation. So let's just say this answer is x and this answer is y, so this is x plus y, and then we have the whole complement, so this will be again a NOR operation. So in total we have 3 NOR operations, so that means we require 3 2 input NOR gates, so the minimum number of 2 input NOR gates required is 3. So doubt is clear. I think this was for question number 14. Now I just want to ask the one thing, actually this struck, okay, now doubt is clear, that's fine. So now I wanted to ask you one thing. Actually I was just going to, in fact I came to know this today, that assignment 2 was had the due date on 8th, right? And our first was our first what is today, just 12th, our lecture was on 12th. So what I was thinking this, should I take those problems also, because now that have been submitted, like assignment 2 has been submitted, so should I discuss those problems also, because now I don't think there will be any issues discussing those problems, because you have submitted the assignment and due date has passed. So should I keep those problems also in my live sessions, or should I do completely new problems, because you have solved those? I thought it will be a kind of a repetition, that's why I didn't keep them. So if you want me from next time, I can keep, because week 3 has deadline when? Week 3 assignment, let me just wait for let me just check it. Week 3 assignment has due date 15th. Okay, week 3 assignment has due date 15th, and which means due date is 15th. Our next lecture will be on 19th, so there will be no issue discussing those problems in our live session. And apart from that, I'll be also discussing some other problems. So you don't have any, it's fine with you that if I discuss those problems? I just wanted that repetition should not be there, that's what I was my thinking. But if you want, I can repeat those problems for you. So because solutions are available, I thought you will look at solutions, but sometimes you don't get the solution. So what I am seeing here is that most of you are saying that discuss them also, but if there are 10 problems, what we can do here, I'll just pick 5 problems that I find interesting, 5 to 6. Then apart from that, I'll keep another 10 to 15 problems from my end, so 20 problems, 20 to 25 problems we will discuss. 50 to 60% problems we will discuss from the assignment that you have submitted, right? And someone had written K-map. I deliberately use very less problems today in today's lecture. I thought maybe in next lecture I'll be focusing more on K-map. So next lecture I'll use be more focusing on the problems that you have already solved, and also the problems that I'll be showing you. I hope today's lecture was clear to most of you. Okay, so if it was clear, I think we can end. If anyone has any doubt, he or she can still ask. We have a couple of minutes. I think 3-4 minutes are there. We can discuss. But other than that, if there are no doubts, I think we can close the session. So I think we can close the session. Thank you guys for attending. See you next week at the same time.